We have a swimmer orients herself perpendicular to the parallel banks. So this is the river. You have bank 1 and bank 2. It's going from this point to that point. If the swimmer velocity is 2 meters per second and the velocity of the current is 0.5 meters per second, what will be her resultant velocity? Also, how far will she actually have to swim to get to the other side of the bank if the distance between the two is 50 meters? So this is the diagram of the problem. I would like to find r. And if you use the Pythagorean formula, so r square is going to be 2 square plus 0.5 square. Right? You need to make sure that you're drawing this correctly. Remember, 2 meters per second is the speed of the lady, the swimmer, and that's a vector. So that should be directed in one direction. And you assume that the current is going to that direction. That's 0.5 meters per second. So r is this one. So if you want to find r, it's going to be the square root of 2 square plus 0.5 square. How much is that? 2.06 meters per second. The other question, we would like to find how far. She's going to be swimming this way, right? Because the water is going to push her away. Now, this angle, alpha, should be the same as this angle because that's the displacement. So if you find this angle here, you will find the same angle, the alpha on the other side. So what do we do? How do you find alpha? Tan inverse? What over what? Over 2. How much is that? 14 degrees. So this one is also 14 degrees, right? So if I have 14 degrees, I would like to find D, the big D here. So that's a triangle. If you look at the formula that we did before, this distance here is going to be d cosine 14, right? So that's the distance, right? Let's say this is a vector and it's called d. Now this one here, the projection or the component that is with the angle, the small one, is going to be d multiplied by cosine 14. So 50, I can say that 50 equals d cosine 14. Then remember, those are vector displacements and then just velocity and position. So d equals 50 over divided by cosine 14. How much is that? 51.5. Now what is that? Meters. Don't forget that meters.